There is a vast, dark ocean between the stars. We call it interstellar space. It is an almost perfect emptiness. And yet, from that immense void, a visitor has arrived. A wanderer. It is a comet, 3I Atlas. Not from our neighborhood, not born from the same cloud that made our sun and planets. It began its journey around another star, countless millennia ago. An ambassador from a distant, unknown solar system, carrying the secrets of its origin. Its arrival gives us a glimpse into the building blocks of worlds beyond. The journey of 3I Atlas has been unimaginably long. Some astronomers believe it could be ancient, perhaps older than our 4.5 billion-year solar system. Imagine that. It may have witnessed the birth of stars we see as faint lights. It drifted through the galaxy for eons, a frozen relic of another time and place. Now its voyage has brought it into our home, captured briefly by the sun's immense gravity. A chance to study it up close. Only the third interstellar visitor we've detected. First, Oumuamua, 2017, strange, cigar-shaped. Second, 2I Borisov, 2019, a familiar-looking comet. Each a unique messenger. Each raises new questions. What are they made of? Where exactly do they come from? 3I Atlas is our latest puzzle, a piece of another star system at our doorstep. We simply have to look and wonder and measure. Every comet that approaches our sun undergoes a dramatic transformation. As it travels from the cold, deep freeze of outer space, the sun's warmth begins to work on its frozen surface. Ice turns directly into gas. Sublimation. Gas and dust erupt outward. Dust and gas form a glowing cloud around the nucleus. That cloud is the coma. For 3I Atlas, the effect was spectacular. Spacecraft watched it race toward the sun. It began to brighten, brighter, brighter, far beyond our model's predictions. It was putting on a show. The climax was perihelion, the closest approach to the sun. For 3I Atlas, that was October 30th, 2025. For a time, it was lost in the sun's glare from Earth. But solar observatories in space continued to watch. They confirmed the surge in brightness persisted through perihelion. The comet was unusually active, releasing huge amounts of gas and dust. This intense brightening is a clue about its nature. Perhaps its surface hid pockets of highly volatile ices, substances that vaporize at very low temperatures. These exposed areas may have erupted like cosmic geysers. Or maybe the comet's structure was fragile. The sun's heat could have caused it to shed large amounts of material. Whatever the cause, this behavior was atypical. It set 3I Atlas apart from many solar system comets. After perihelion, astronomers waited for its return. On October 31st, 2025, the Discovery Telescope in Arizona captured the first post-sun image. The visitor had survived, a faint fuzzy patch in the dawn sky. A smudge, but an important one. It meant that our chance to study this interstellar object was not over. And the most exciting part was still to come, a closer pass by Earth. One of the most fascinating things about comets is that they don't always follow the strict path laid out for them by gravity. As the ice on a comet's nucleus turns to gas, it can shoot out in powerful jets. These jets act like tiny rocket engines, giving the comet a gentle but persistent push. We call this non-gravitational acceleration. It means the comet's orbit changes in ways that the pull of the sun and planets alone cannot explain. For 3I Atlas, this effect was noticeable. It seemed to be getting a push, altering its trajectory as it flew through the inner solar system. The sheer speed of this object is difficult to comprehend. 3I Atlas was clocked moving at more than 130,000 miles per hour, or about 210,000 kilometers per hour. That is fast enough to travel from London to New York in less than 2 minutes. This incredible velocity is the key signature of its interstellar origin. No object bound by our sun's gravity could naturally achieve such a speed and be on this kind of open-ended path. It is moving too fast to be captured. It is destined to fly past us and continue its journey back into the vast emptiness of interstellar space, never to return. The non-gravitational push on 3I/Atlas adds another layer to its mystery. While we expect comets to have these little jets, the force on this particular visitor seemed significant. Was this because it was made of materials that turn to gas more vigorously than the ices in our own comets? Or was the shape of the comet or the way it was spinning causing the outgassing to be particularly effective at changing its course? These are the questions that physicists and astronomers ponder. By measuring the push precisely, we can work backwards and try to deduce the properties of the object itself, even though it is just a tiny point of light millions of kilometers away. This acceleration, combined with its extraordinary speed, paints a picture of a dynamic and active world in miniature. It is not just a dead rock tumbling through space. As 3I Atlas got closer to the sun, reports began to circulate that it had turned a striking blue color. This idea captured the public imagination. An alien comet, changing color as it met our star. However, the reality is more complex and more interesting. The color we see is often the light emitted by specific molecules in the coma as they are energized by sunlight. Certain gases, like carbon monoxide, can glow bluish. One astronomer clarified, the comet's color change was mostly the coma brightening as it warmed and released gases. The blue wasn't the solid nucleus, it was the temporary atmosphere, the coma. The real surprise came not from our eyes, but from advanced instruments. Using the Very Large Telescope in Chile, astronomers split the comet's light, producing a rainbow spectrum. That spectrum is a chemical fingerprint. What they found was puzzling. The spectrum showed a strong nickel signal. The iron signal, however, was weak. This imbalance was unexpected. In our solar system, nickel, iron, are cosmic partners. They're forged together in dying stars and appear together in predictable ratios. But around 3I Atlas, there was far more nickel than iron. The discovery sent ripples through the scientific community. Why would this be? Was the comet formed in a region with a different chemical makeup? Or is some process on the comet releasing nickel more efficiently than iron? This chemical anomaly is a profound clue. It suggests the parent star system might be very different. Perhaps the parent star had a different composition, or planet formation there works in a way we haven't seen. A stark reminder, our solar system is just one example among billions. By studying the light from this visitor, we're doing remote chemical analysis of another part of the Milky Way. The high nickel to iron ratio is a real scientific mystery, and it requires more observation to solve. With so many unusual characteristics, the intense brightening, the strong acceleration, the strange chemistry, it is natural that some bold ideas would emerge. The astronomer Avi Loeb, known for his unconventional theories, pointed to these anomalies and proposed a provocative possibility. He suggested that 3I Atlas might not be a natural object at all, but a piece of extraterrestrial technology. This is an extraordinary claim, and as is always the case in science, extraordinary claims require extraordinary evidence. Most scientists urge caution, emphasizing that natural explanations must be fully exhausted first. The scientific process thrives on this tension between convention and speculation. While the idea of an alien probe is exciting, the current data can likely be explained by natural cometary processes that we just don't fully understand yet. The unusual chemistry could be a result of how different ices sublimate at different temperatures, or it could reflect a genuine difference in its home star system. The acceleration could be caused by the comet's unique shape or rotation. The beauty of science is that we don't have to guess forever. We can collect more data to test these ideas. The truth is written in the light of the comet itself. So, what do we know for certain? And what remains a mystery? We know 3I Atlas is from interstellar space. We know it is moving incredibly fast. We know it brightened significantly and showed non-gravitational acceleration. We have measured an unusual ratio of nickel to iron in its coma. These are the facts, grounded in observation. The unknowns are the why. Why did it brighten so much? Why is its chemistry so peculiar? What is the true nature of its composition and origin? These questions are the driving force behind the ongoing observation campaigns. The story is far from over. As we stand here on November 11th, 2025, the comet is set to make its closest approach to Earth around December 19th. As it gets nearer, our telescopes, both on the ground and in space, will get a better and better view. They will gather more detailed spectra and sharper images. This new flood of data will be crucial. It may confirm the strange chemical signature or show that it was a temporary effect. It will allow us to refine our models of its acceleration. 3I Atlas is a gift from the galaxy, a puzzle box that we now have the privilege to try and unlock.